In this chapter, we will study the fluid mechanics. So far, we study the mechanics of the particle. That is, we study the motion of the particle, the cause of the motion of the particle, which is the force. Okay, but that is only one part of the mechanics. We now move to study the motion or the mechanical property of the fluid, which is very basic because the fluid mechanics is one of the most complex topic in physics or in mechanics, and nowadays we still not fully understand the property of fluid, even the very simple fluid, because it is very complex. And in this chapter we will focus on some basic property of the fluid, and mostly we will assume that we are working with the idea of fluid, especially when we talk about the fluid dynamics. Okay, and the topic of this chapter, we have 7 topics. The first 4 sections are the topic of fluid static. Okay, the section 14.1 to 14.4 is the fluid static. The fluid static, okay, which means we study the fluid that not move or at rest. Okay, we study by define the most important concept, that is the pressure, and then we go to the variation of pressure with depth, and how do we measure pressure, and the buoyant force and Archimedes principle, and they are in the topic of fluid static. The next 3 sections, section 14.5 to 14.7 is the fluid dynamics. Fluid dynamics. Okay, it's the fluid dynamics, which means that we study the fluid that move, and the most important principle is the Bernoulli equation, which equivalent to the conservation of energy in the particle dynamics. And we end this chapter with the application of fluid dynamics. We start our study in this chapter by discuss the state of matter. In general, we say that we have 3 states of matter, okay, which is solid, liquid, and gas. Some people may say that we have the 4th state of the matter, that is the plasma. This is the fourth state of the matter. Plasma is the gas that all atoms in that gas are ionized, which means that the positive charge and negative charge are separated in that gas, and it has the property that is very different from the normal gas. And some people say that that is the fourth state of the matter. But okay, here we will stick on the conventional definition. Leave this plasma state for the advanced study of now. Okay, so we assume that we follow the conventional definition, that is, we have the solid state, liquid state, and gas state. The liquid and gas state, we can say that in these phases, the object is in the fluid state. The fluid means that when the object in the object is in this state, it can flow. Okay, you can see that when an object is in the solid state, it cannot flow. Okay, it can move, but it cannot flow. But when it is in liquid or gas state, it can flow. For example, the water, when it is in the form of ice, it is a rigid body and it cannot flow. But when it's in the form of water, liquid water, or the vapor gas, it can flow. So that is the difference of solid and fluid. And you can see that liquid and gas has this common property, that is, they can flow. But the difference between liquid and gas is that for the liquid, okay, let's talk about the one another common property of liquid and gas, that is they can the shape can easily change. This is another common property of liquid and gas. You can see that when an object is in solid phase, it's hard. If it is a rigid object, rigid body, it's hard to change their shape. Okay, if it's a soft matter, we may be able to change the shape, but when we compare with the liquid and gas, we can very easily change the shape of the liquid and gas. Right? When you pour water in any container, the shape of the water is the shape of the container. When you fill the gas in a chamber, the shape of the gas is the shape of the chamber. Okay, so liquid and gas can easily change their shape, but solid is not in general. Okay, but liquid and gas also have different properties. The most important is that the volume of liquid is use this word maybe more proper. The volume for liquid is not or cannot easily change. I mean that if you pour water into a container, okay, the shape change, but the volume is not change. If you have an amount of water, if you fill it in different container, you have different shape, but the volume is the same. So it means that we cannot easily change the volume of the liquid, but for the gas, the volume can easily change. The volume can easily change. You can see that if you, for example, if you have a balloon, you can compress it to make it smaller. You can heat it to make it expand and to make the balloon larger, and that is very easy. You cannot do that to the water. In normal condition, you cannot compress the water. You cannot make it expand. In fact, you can do that, but it's not that easy compared to the gas. So, a different property of liquid and gas is that it's about the volume. In the case of liquid, we may say that for normal liquid or and normal condition is incompressible. It means that you cannot change or you cannot compress the liquid. You cannot change its volume or you cannot compress the liquid. But for the gas, it's compressible. Okay, so that is the difference.